This is question number 5 taken from exercise 8.1, chapter quadrilateral class 9. It says ABCD is a parallelogram. This figure ABCD is given a parallelogram. Further, P and Q are points. As you can see, P and Q are points. They are taken on the diagonal BD such that the DP is equal to BQ. That means we are given this length is equal to this length. What we have to prove in this figure is to prove two triangle congruent. That means the triangle we need to prove congruent here are these two. Let me show you. We have to prove this triangle, say this one. We need to prove this triangle, that is APD congruent to BQC. Now let's see how we can prove these two triangle congruent. First of all, we know that opposite sides of parallelogram are equal. So I can write AD is equal to, BC. Reason is opposite sides of parallelogram. Further, you can see this angle is equal to this angle. They are alternate interior angles. As you can clearly see that they are formed by parallel lines. Since this is parallel to this, that is opposite sides of a parallelogram are parallel, and considering this to be the transversal, you can see is forming like a Z, and therefore this angle will be equal to this angle, and that's from the alternate interior angle. Further, we are also given the length of these two sides as equal. That means DP is equal to BQ, and that is the reason here is given, right? We are given here. So straight away now we can say these triangles are congruent, and the reason will be from SAS. Once the triangle become congruent, you can write AP is equal to CQ, and the AP is equal to CQ. The reason here will be CPCT. That is corresponding parts of congruent triangle CPCT. Once we are done with this, now let's see what other things we need to prove. As of now, we have proved AP is equal to CQ. Now, in the next part, we have to prove these two triangle congruent. Here, the triangles we need to congruent is AQB, that is this triangle. AQB is this one. To prove this triangle congruent to the another triangle, let me highlight in the triangles, which I mean to say. This is triangle AQ. This is one triangle, and the other triangle is this. We need to prove these two triangle congruent. Clearly, the triangle is AQB and CPD. Now, it can also be done in the same manner as we did the first part. So here also you can see that AB is equal to CD. Why? Because they are opposite sides of parallelogram. So AD/AB is equal to CD, opposite sides of parallelogram. Further, you can say the length BQ is equal to DP, and that is from given. And this angle is equal to this angle, that is angle ABQ is equal to AD. Sorry, we did something wrong. Here the triangles angles congruent are this. That is angle ABQ and CDB, and they are alternate interior angles. As you know that whenever two lines are intersected by a transversal, then the alternate interior angles are equal. Here the alternate interior angles has to be this and this. These two angles are equal as they are alternate interior angles. So we can say that these two triangles are congruent, and likewise the previous way, this also can be written by side angle side. Once these two triangles are congruent, we have to find or prove that AQ is equal to CP. AQ is equal to CP. And that's what we can write from CPCT. As you know, when two triangles are congruent, their corresponding parts are equal. Now, in the next part, we have to see what we have to prove is APCQ is a parallelogram. So let's figure out which one is APCQ. So This is APCQ. This one is APCQ. We need to prove this figure as a parallelogram. Yeah, so you can clearly see that we actually have proved two opposite sides equal. I mean to say, here we have proved AP is equal to CQ, and we have also proved AQ is equal to CP. Once again, I should show you, we have already proved AP is equal to CQ, and we have proved AQ is equal to PC. As you should know that when two pairs of opposite sides of a quadrilateral are equal, is a parallelogram. So what you will be writing simply from, this can be written from second is this and fourth. So you'll be writing from second and fourth. And the reason here, as you know, that two pairs of opposite sides are equal. Opposite sides of are equal. So any quadrilateral when two pairs of opposite sides are equal is a parallelogram.